Hello. Today I'm going to be going over how to make a Go binary and how to do it in an idiomatic way. I've been working on Go files and on Go programming for many years now, and I think it'd be useful to show the general structure I go about whenever I'm creating a new binary. And by binary, I mean something that I plan to package and have developers run from their laptops or from their dev machines. So first, we're going to start with a new file, main.go. It's a package main. This requires, obviously, a function main. And then the main function returns no errors. So test it, go run main.go. Package main, didn't save it. Yep, everything works. Now, one notable thing about Go is Go has a very specific way for handling errors. Unlike Java and Python, which use exceptions that get thrown, Go uses return values. And so you'll see a lot of times you'll see error equals some function, and then if error does not equal nil, return the error. And we can use this in the main function to make our program look more clean and more idiomatic Go. And to do that, what we can do is we can abstract out part of our tool that returns an error and separate it into a separate function. And so we can create a function called run that returns an error. And then for now, it'll just return nil. And then now from our main function, since it doesn't return an error, we can do print f error %v and then os.exit1. Obviously, if you have a more complicated exit code system, you can have your error be a specific type that has an exit code, and you can use errors as to return specific exit codes. But here we're just going to use exit code 1. One thing to make this even more idiomatic is error should only be scoped to this if statement. It's not used outside of it down here. So we can actually use some nice Go syntax and put it inside the if statement, which scopes it down to just this. Sweet. Now let's begin creating our package. So what I want this command line to do is pretty simple. I just want it to convert YAML into JSON. So we're going to create a name. We're going to call it YAML to JSON. And then we're going to create a flag set. So you may be tempted to do something like this. New flag set. So flag sets allow you to parse command line flags. You may be tempted to do something like this. But since flag, as we see here, flag actually is a unique package in the sense that it has a flag set and it has package level functions like string, and the flag set actually implements almost the same functions as the package level value. And so the proper way to use this, as I generally prefer, is you actually overwrite the keyword of the package to be a new value, and that way you don't accidentally reference the package when you're trying to reference your flag set. So new flag set, we can look at it, but it takes a name and an error handling. In this sense, in this specific situation, we'll just use exit on error to be simple. So name, and then flag.exit on error. Sweet, let's create two arguments, the input and the output. The input will be a flag.string. This one will be pretty normal input, default values empty, input YAML document to convert. And then the output similarly will be string, output empty, and then output JSON document And then the interesting part for this one is we'll default a ULT to standard out. And what this means is a user can not supply an output flag, and it will pipe it to the standard out so that they can utilize it on their command line, doing different things, like piping it to a different binary or such. Awesome. So first, we need to parse the flags. So flag.parse. And one awesome thing about a flag set is normally flag.parse doesn't take args, but it does if you use a flag set. So we can actually specify which args are going to be used, which is os.args. And generally the args are these. And so the first argument is actually going to be the name of the function usually. So we can usually leave that one out and do one onward. And then if error is not equal nil, return error. So by abstracting away the run, it's much more easy to handle these errors, as you can see. Awesome. Let's begin by reading our file. So our YAML bytes will be os.read file. And then OS takes a few arguments. So in this case, let's just make sure we're getting them correct. So OS, we have read file, name, bytes error. Awesome. So YAML bytes error, OS read file, input. We do want to make sure that this input flag exists. So we can say if, to be really safe, input should never be nil because flag.string guarantees it. But we can be safer, say if input equals nil, or just to prevent a panic, if input equals empty, return errors.new, input flag is required. You'll notice that I use errors here. A lot of times people use FMT error F. Generally, the correct practice is to use errors whenever there's no formatting directives, but if there becomes need for a formatting directive, then you use fmt.errorf. Cool, so let's bring in our things we're using. Flag. I don't have a formatter installed, so we're just gonna sort things alphabetically ourselves. So in this case, because this is an important one, because we're opening a file and we're going to need to open other files, we will need more context in the error message than just file failed to open. So we can do that by wrapping an error like I was previously discussing and saying the input YAML file failed to open. Then we wrap our error. And this allows, using the wrap means that the caller can still type match on this error, but wrapping it provides more context. So this is the idiomatic way to wrap an error. Awesome, now we have our bytes. So generally when unmarshalling things, you want to unmarshal into the strictest possible structure that you know of. But in this case, we don't really have any structure, so we can use a map of a string to an interface, and this will encapsulate all possible types here. So let's go ahead and make a test YAML. So test2. That should not be, whatever. Value 1 values list equals list of be a list of things. All right, so test.yaml. Let's make sure that this is working. So if error equals yaml.unmarshal YAML bytes, and then data. Let's go look at YAML. So if we go to Go docs, YAML v3, that's a good one. So let's go with that one. If YAML unmarshal that, errors not equal nil, return error. So now let's just run this to make sure things are working as we expect. We do fmt print f % plus v, which prints a structure and its values, and then we're gonna say data. So go run main. No required package. Cool, so let's do go mod init. Let's call it test. Okay, now we need go mod tidy. Okay, so that just installs the stuff we need. Go run main. Output declared and not used. We'll comment it out for now. Input test.yaml. Nice, it works. So technically we would actually want to say print working directory test.yaml because you don't actually know the invocation location of your binary. Here we do because we're calling it directly. Let's go ahead and continue. So here, let's first say let's first assume output is full. So we have a file, error, os.open file. Let's go look at what os does. So open file requires some things. It requires a name, a flag, and then permissions. So here they use read, write. Let's go look at the constants to see what the options are. We want write only, and we want create. So we want to create a new file if nothing exists. But it's okay if we override the file. So we're going to do that. We're going to do write only and create. And use our output file. And then we're going to say 644, which is read and write. Now, again, since we're dealing with files, we want to be more explicit about how our error is handled. So we're going to say output JSON file failed to open. So that way we have more context over which file is failing to open. Cool. So now we could do something like, so our JSON bytes error equals json.marshal. We want to marshal our data. And then our data is, that's all we need. If error is not equal nil, return error. It's pretty clear if we're marshaling JSON that the error is from that. So this is nice, but if, so then we want to file.write our bytes, but if our output equals empty, then we want to write our bytes to os.standardout. And so what you'll notice here is we have a pattern that we can abstract away. And that pattern is we have a function write bytes to file, or we'll just call it write bytes, that takes to an output, which is an IO writer, and the bytes, we'll say B, because bytes is a protected keyword, so we'll do BS, is an array of byte. And that can return an error. And so what that means here is we can use the interface of an I/O writer. So if you go look at the I/O writer interface returns it returns two things, an int and an error. But in this case, we don't care about the position of where we stopped writing. So we can just use the error and say out.write BS, then return error, of course. And so now by abstracting this out, what we can do is we can say if output equals that, or first if output equals nil, which it will never be, but it prevents a panic, so we might as well, or the output equals empty, then write bytes to our os.standardout. Otherwise, write bytes to our file. And so there's even more things we can clean up here, and I think it'll be pretty clean at the end. So one thing different between a file and standard out is you have to close a file. And so generally, whenever you open a file, you should immediately defer a close. And so that handles that because this goes on the top of the call stack, and it gets executed first thing after the return. So no matter where we return here, it'll close. Next, we only want to open the file, obviously, if this isn't equal to nil. So we can move all of this stuff into here. And since this is actually the end of the function, we can go even further and just if the output is nil or the output is empty, we return the error from write bytes, and else we can reduce the nesting by getting rid of that else, because we always return here. So this is by default else, and we can just continue on and then return our last write bytes. Nice, so this is pretty idiomatic as is. Bring this down. Pretty idiomatic as is. There's a couple things we can still do to clean up that I think are worthwhile. One is OS args and OS standard out are part of the environment technically. They're part of the OS package, which means they're connecting to the environment. This run, we want it to be testable. So we really should be taking our args as an input and also our standard out as an input. And then going even further here, we're printing. When a package fails, it should always print the error to the standard error. That's what it's there for. So we should print f, the standard error. And now we have most things good. And then our OS standard out is now our standard out. Rather than marshalling directly, let's actually marshal indent so it's easier to read. So the first argument is the data, second argument is the overall padding, and the third argument is the indent size. I'll just do 2 spaces. So let's go run. All right. So we need IO. We need encoding JSON, and then we need OS dot and OS dot. Non-F file. All right. Yep. We have to write our bytes. So JSON bytes. And JSON bytes here. So that's good. Not enough calls into run. Yep. So we want os.args here. and then our os.standard output. And so now we've fully parameterized everything in the run function. We're actually inheriting nothing from the environment. Everything is provided through different arguments. And so what that means, as you'll see, I'll put output here. So output equals test.json just to show you. Now that we've created our binary, we can go ahead and make a test for it. You'll notice that the majority of the work we did to test it was actually in how we structured our code. So it's very important when you're writing code to think about how you can extract the bits of information that attach it to systems on the computer, like the arguments and the standard out, and extract them to be arguments of your tool or whatnot. So I've created a file, main test.go. Let's open a terminal here. Let's first run go test. So we're gonna say package man. And we have no tests, so it should pass. All right, so we need to import testing. And then I highly recommend, just to make things clean, to use stretcher testify. It's a really simple API for testing, and I think that it makes things much more clean than using the base testing package for asserting errors and such. So we're going to use testify assert. So now function, we're going to test run. And so run actually has the majority of our logic, so we can test most things. From there, takes the testing t as an argument. Let's start with a basic happy case. So we're going to have a input file. I'm going to create a new folder, test data. We're going to create a new file, test.yaml. We're going to move our test into the test data. So generally you always want to have your test data in a file, in a folder called test data. That's the general structure of how most Go code is written. So our input file is going to equal /. You want a relative in this case, in case you move the test around. Test data / test.yaml. And then you want to run, and then output file equals, we'll create, so first we'll create a temp directory. Tempdir equals t.tempdir, and then our output file will be a file path.join. And so we're going to join our tempdir with our output file path. So we'll do output.json. So the reason we did this is because we want to make our tests hermetic, and we also want our tests to be not leave anything behind. So by hermetic, I mean it doesn't depend on anything outside of this package, and we also want to make sure that if we run it multiple times, it doesn't mess up because it saves some file somewhere. So creating tempdirs is nice because after the test is done, it deletes the temp directory for you. And then now we need to structure these as args. So we'll do args equals string, and we're actually going to go ahead and pretend we're using it just like the flags. So you can do it a couple ways. You can either do, input equals and then that, but we might as well just separate them out. So input equals input file, and then output equals output file. And then run args, and then let's look at our run function. We have these standard out for now. Since we've provided args, let's just do io.discard. Now let's run go test. No required modules, go mod tidy. Go test. And then let's, just for fun, let's say assert.equal. So let's get the data, or out error equals os.read file, output file, and then assert.no error, error, and then assert equal, let's say our out and something else. We'll use an empty string for now, and then we also need to assert no error on the run, because run returns an error. Cool. So let's go test. Undefined file path. Path, file path, undefined IO, IO, OS. Go test. Fail. Flag provided but not defined. Oh, I see. We forgot to replace our args with args. See, that's a good catch. Our test was caught a bug in our code. Cool. Let's go ahead. All right, so this is hard to see, but assert equal, you want to have your want first and then what you got next. So we'll call this got. And also, this is not readable, so I almost always recommend converting any sort of bytes to a string before running them in a test. Cool. Now let's run go test. And we got this thing. Of course we did. That's what we expected. So let's take this. Let's move our test JSON to the test data. And then let's read this too. So let's say that's what we got. So let's first load what we expect. So expect read file dot slash test data slash test or output dot JSON. And then we need to assert no error here. And then we want our string of expect equal to our string of got. So let's run it. Okay. So not equal. Oh, I called it something wrong. So we'll call it test.json. Now that we've done that, renamed it test.json, let's run go test. Pass, okay, awesome. Couple more things to make this more idiomatic. We are creating a temp directory. We're creating a temp file. This is all good. Then we run, but if we get an error here, we actually don't want to check the output file because something's wrong. So that's where this package called require comes in. So require is very similar to assert, except generally you want to use require whenever something goes wrong you don't want to continue. So for example, in these three situations, if we get an error, we don't want to continue. So we're going to do go test, and it's going to be okay. Now let's do one more test. Let's do a couple more tests. We'll test run 1 where we have no output, and so we'll remove our output, and then we'll create an out buff, which is a bytes.new buffer. And then this will actually be our standard out. So we'll just call it standard out actually. So our standard out is bytes.new buffer. Then we'll pass it into the argument. We don't have an output file. We don't need to read our we don't need to read our output file, but we just need to get our standard out.string and assert on that. So that tests the other case. And then lastly, let's test one error case. Let's test that it fails if the input flag doesn't exist. So actually, let's do it. Let's do it instead because it's more interesting on a bad input. So doesn't not exist. So we'll try using not exist. And if we run go test run bad args, go test. Not enough argument, but it's a new buffer. Input file declared not used. Input file. Tempter declared not used. That's the same here. Okay. Bytes.new buffer nil. Cool. YAML file, the input YAML file failed to open. So now we can do something and where we can create an error check, but not make it a change detector. And I like to use error contains for that. So error contains, run returns our error. And then we can assert on just part of the error message. So let's just assert that the error has input YAML file as part of the error message. Cool, now we are just asserting that the error returned from run contains input YAML file. And we can run go test and show that this will pass. And we've created a pretty good test because we can test almost everything in this function. As you can see, we're testing the inputs. We can test bad flags if we wanted. We can test reading the file fails. We can test bad YAML. And we can test some YAML that can't be converted to JSON. And we can also test bad output file paths. Maybe a directory already exists there or something and we can't write to it. So there's a lot of potential for how we can test it, and it's all because we structured it properly. So I hope this was helpful. I hope you're able to write more idiomatic and testable code. And thanks for tuning in.